Now, in this lecture, I'm going to introduce you to carrying out logistic regression using Pytorch, and we are going to work with an inbuilt data set called MNIST. Now, if you have installed Pytorch correctly, you should be able to import Torch from Torch AutoGrad import variables, transforms, import Torch vision.datasets as dsets, and this is where you get the built-in datasets from. Now we are going to load the inbuilt dataset MNIST. So I've got two variables, train underscore dataset and test underscore dataset. Dsets, that's where my inbuilt datasets are. Dsets.mnist root data train true transform. I have an argument called transform. This is equal to transforms to tensor, download true, which means I want to download these data, and transforms to tensors. This is going to convert my data into tensors. So even when you use inbuilt data sets, we are going to need to convert them to tensors, and we do something similar with the test data sets like so. And all of these have now been downloaded for me. I'm going to make my data sets iterable. So for that, I have variables train underscore loader and test underscore loader, torch utils data loader, and train data set shuffle true over here. And this will just allow us to iterate through these data. Now we are going to create a model class to define the architecture of logistic regression. So for that, I define an actual Python class called Logistic Regression, and because I say use the keyword class, it means this is an actual class, and torch nn module, and here I define an actual function, so def init, and this is to initialize my model, super logistic regression self init, self linear, torch nn linear, input dimension, output dimensions, because we are going to input something and then get an output. And then I create another definition, forward self x, output self linear dot x, return outputs. We can decide on the batch size 100. We are going to have about 3000 iterations, epochs, numbers of iterations, and divide by the length of the training data set. The input dimensions are 784 because this is how the MNIST data are. So these are imagery kind of data, pixels loaded into a flat format. So in this case, the dimensions, I do know they are 784. Output dimensions are going to be 10, and this is because we have 10 response variable classes which vary from 0 to 9. That's why my output is going to be 10, and this is going to be my learning rate. So I define my model in the variable model, logistic regression, input dim, output dim. Then in order to compute the losses, I define I'm going to compute the softmax and cross entropy for the losses, criterion torch NN, cross entropy loss, optimizer torch optim SGD, model parameters like so. Now I start from the first iteration 0 for epoch in range epoch. So for each epoch, for I in images, labels, enumerate train loader, images variable 28 by 28 because those are the pixel size. Labels are the classes 0 to 9, variable labels, optimizer 0 grad, outputs model images, loss criterion, output labels, loss backwards, and then we are going to essentially for each of these we are going to compute the accuracy like so. So we can see by the time we have so many iterations, we get an actual accuracy of about 89%, and this is basically, so this is a very brief example, and this is how we actually end up setting up logistic regression using Pytorch, and in this case on an inbuilt data set.